Proportions are simply this, equivalent fractions. That's all they really are. Let me show you an example here. So here we have 1/2 is equal to 2/4. Let me just draw a quick sketch of 1/2. So I have one whole amount is going to split up into two parts. And I'm looking at one out of those two slices. So I'm going to shade 1 out of 2. That's 1/2. On the other side, same idea. I'm going to draw another rectangle to represent 2/4. So basically I'm going to cut it in half. And then cut it in half one more time. So I can get 4 equal slices. And then I'm going to shade 2 out of those 4. So that's 2/4. You can see that 1/2 and 2/4 are the same thing. Right? Half of the whole figure is shaded. Now, if I wanted to make the 1/2 look similar to the 2/4, I would do the same thing I did in the other one. I would just basically cut it in half one more time. And you can see that I actually have 2 out of 4 parts shaded now. And without a picture, all I really did was this. So I started off with 1/2 is equal to 2/4. And I just doubled each amount, right? In the original, I had 1 part shaded out of 2. And when I cut it in half, it became 2. So I basically doubled the numerator. And then for the denominator, what I ended up doing was, we started off with 2 parts, right? It was cut into 2 parts. And then after I cut each part in half again, I ended up with 4. So I doubled that as well. And now you can see that we just multiply the numerator and denominator by 2, and we get 2/4 is equal to 2/4. Equivalent fractions. And equivalent fractions, don't forget, that's what a proportion is. There's nothing more to it. And if proportions are simply equivalent fractions, we can use that to solve for missing values, like in this equation here. All you have to do is find a common denominator in this case. So, since I have here x over 4 is equal to 6/8, I will find the LCD, which I know would be 8 in this case. And I ask myself, okay, what do I multiply the 4 by to make it into an 8? And in this case, it would be times 2. And I'm going to do the same to the numerator. And I would get 2x over 8 is equal to 6/8. And now that we have equivalent fractions, don't forget, proportions are the same, have the same values in the numerator and denominator, just like we see it in the previous example. Which means that these two numerators have to be equal to each other, because we already know the denominators match up, the bottom numbers match up with each other. Then the numerators, the top numbers, have to be the same as well. Which means I can write a new equation. 2x has to be equal to 6. That has to be true in order for these two fractions to be equal to each other. Which means if I wanted to solve this now for x, all I would do is use the division property of equality and divide both sides by 2. And you can see that I would get x is equal to 3. And that would be my missing value. And if I wanted to double check that that makes sense, I would rewrite the original problem. X over 4 equals 6/8. I'm going to replace the x with the answer I got, which we got here. X is equal to 3, so I'm going to replace the x with the 3. And I'm going to get 3 over 4 is equal to 6/8. And we can see that if I were to rewrite these into a common denominator, I would have to multiply the numerator and denominator by 2 here, so that the denominators match up at 8. And I would get 6/8 is equal to 6/8. So these two fractions are equivalent. Let's look at another example. In this example, you can see that the denominator has the variable that's missing. So what I'm going to do in this case is find a common denominator. And in this case, what I would have to do is, since they don't have the same values and one of them is a variable, I can do this. There's two options. I can multiply the right side by x, and I'll have to do the same to the numerator. And on the left side, I'd have to multiply it by 5, and the same to the numerator. And by doing that, you can see that I would get 20 over 5x equals 6x over 5x. But you can see we end up with too many variables, and I don't want to do that because it kind of gets too complicated. So I'm going to redo this in a different way. So I'm going to go a different route. And here's what I recommend. I would find the reciprocal of each fraction, meaning you're going to switch the numerator and denominator. So I would get x over 4 equals 5 over 6. So you can see basically I flipped each fraction. And as a side note, you can see that that works because let's say I had something like 4 over 3 is equal to 8 over 6, which I know are equivalent. If I were to switch that around and put 3 over 4 is equal to 6 over 8, I can see that those fractions are still equivalent because I can multiply both of these by 2 and I get 6 over 8 no matter what. Same thing in the original example, right? If I doubled each one, it's still going to equal to each other no matter what. So as long as you have a proportion, you could flip each side and it comes out to be the same thing no matter what. So I'd recommend doing that if your unknown value is on the bottom. And now we can proceed with finding the common denominator. So in this case, 4 and 6, I know the least common denominator would be 12. So I ask myself, what would I multiply 4 by to make it into a 12? It would be a 3 in this case. I'll do the same to the numerator. And on the other side, to make the 6 into a 12, got to multiply it by 2 to both the numerator and denominator. Now I'm going to simplify. 3x over 12 is equal to 10 over 12. And now you can see that the denominators match up, which means that these two numbers have to be the same if those two fractions are going to be equal to each other. Which means I'm going to get 3x is equal to 10. And now if I want to solve this, I'm just going to use the division property of equality. Divide both sides by 3. And I would get x is equal to 10 over 3. And if I wanted to do a quick check, I would just rewrite the original. X over 4 equals 5 over 6. I'm going to substitute the answer we got 10/3 in place of x here because they're equal to each other. And I'll get 10 over 3 divided by 4 is equal to 5 over 6. Let me just move this down a little bit. And if I were to rewrite this complicated fraction, it's the same thing as saying 10 over 3 divided by 4 is equal to 5 over 6. So I'm dividing it by 4 over 1. And if you've studied division of fractions, you know 10/3 divided by 4 over 1 is the same thing as multiplying by 1/4. So by multiplying the reciprocal, you're going to get the same thing as dividing by 4 over 1. They're the same thing. And now if I multiply across, I get 10 over 12 equals 5 over 6. And you can see that these two fractions are equivalent because if I were to divide each of these by 2, I would get 5 over 6. And that's all there is to it. I hope these examples help out.